Hello and welcome to Game Design and Development. I'm going to be doing this first video series on a top-down 2D game, and we'll have an alternative series for this 2D project for a 2D platformer. So the top-down 2D game will be something like Legend of Zelda, like the classic ones, or maybe like Stardew Valley, or maybe like Undertale. And the platformer would be something like classic Mario platforming games or maybe like a Metroid game. So we're going to start right now with a top-down 2D game. Everyone should have Unity Hub downloaded. If you don't, that's the starting point for this. Go online, find where to download Unity Hub. Make sure your version is the same as mine. I'm using new project. I'm using Unity 6. As long as you're on Unity 6, it should be pretty much the same. So we're going to start by clicking New Project. I'm going to make it a Universal 2D project. I'll name it my name. I'll name it my name. And I will just put Top-Down 2D Video Guide. That's what I'll name this. So this will be the video guide for the Top-Down 2D series. We name it here. This doesn't really matter for you guys. I'm going to put it in my game dev class though. I'm going to turn on your version control. This is probably not going to work for you at first. You guys can go online and look up a guide on version control. I'm probably going to do a video later on getting your version control set up. You do not need it set up now. You can set it up later. And setting up later has in the past generally been a little easier for my students. So I am going to start mine on version control. Once I create project, it will start opening up Unity and we'll start exploring it together. I will cut the video until it opens up. Alrighty, so we are now in Unity. We're ready to start building our 2D game. Before we do so, let's get some simple vocabulary out of the way. We have a few windows that we can see in our Unity. We have our hierarchy on the left side. Our hierarchy shows all of the game objects that are currently in our game. Right now, all our game has is a global light and a camera. And if I go to this hierarchy window and I right-click it, I could add new game objects. Everything in a Unity game is a game object. If I add a square to my game, maybe rotate a little, maybe stretch it, whatever, now I have another object in my game. My hierarchy is my list of game objects. If I press play, I'll be able to see my square in the game once it loads. And this is a object that is in my game. It's just my stretched out square. I can color it if I want. Maybe I make it green. And maybe I actually set the rotation to 0. And all of these things I'm messing with now, the rotation, the color, these are different components of this game object. We added this square game object. I can change its scale. I can change, well, the Z scale doesn't really matter in 2D. But I can change the scale of the object. I could change its position. I move it up and down. I can change its color. These are all different kinds of components that I have. My transform component determines where objects are. The renderer determines what my objects look like. Now, I've moved this game object that I added to my hierarchy, and I've changed its properties of its components in the inspector to make it kind of look like grass at the bottom of my screen. I'm actually going to make it a little wider, and I'm going to make the grass a little darker. And maybe this will be the floor. Now, in addition to the hierarchy and the inspector, which lets you add game objects and then edit the components of those game objects, we also have our projects folder. Our projects folder holds all of our assets. Assets are not necessarily in the game. Assets are all of the files and so files might be like pictures, videos, music files, not so often videos, but potentially. Assets are all of the files that are in our game. So I'm going to add a new asset. In my assets folder, in my projects window, I'm going to create a folder, and I'll call this art assets. And now I can go to my computer files, and maybe I can drag in some pictures from my computer. Maybe I have this little crab guy, put him in my art assets. I was making a fish game earlier. Maybe I put a little lionfish in. Maybe I put this snail in, and the details aren't going to be perfect on these things because they don't have transparent backgrounds or anything, so they're going to look a little silly, but it's fine. I'll throw in those 3 art assets. Now I have these files in my game. If I want to take an asset and turn it into a game object, I can do that by just dragging an asset and putting it into my game, and now I have this game object. So I will just rename this crab. I'll just call him player. And now, when I press play, I have my player game object that I built from an asset by dragging an art asset into my game. And he's in my little green map. Now you might notice a few things about my player. Is the first thing we might notice is that he does not have any kind of physics to him at all. That's because we're missing some components from our game. A component is things like the renderer or the transform. The components have different properties in our game objects. The first thing we're going to do to start making this player, playable, is I'm going to add a component, and I'm going to give him a rigid body 2D. Rigid body 2D is the physics component in the 2D game engine. If you're working in 3D, you would just use normal rigid body. Now he has a rigid body 2D. This rigid body is the component that affects the physics engine. So we have some mass, some gravity. We have all kinds of different physics properties. When I press play, since he has this physics component with gravity set to 1, he will start falling down. He will start falling down now. Cool. But he fell right through the floor, which is not ideal. So we're going to need another component to solve that problem as well. Our game objects are going to have these 3 basic components almost every time. 4 basic components. They're always going to have, almost always going to have, they're always going to have a transform. A transform is going to be where the object is, how big it is, its rotation. That's about it. This transform component is going to be in every single game object in your game. Even in the camera, I have a transform. In my light source, I have a transform. Every game object has a transform. A renderer is a very common game object component. The renderer component is going to render the game object. Rendering means we can see it. A renderer lets us see it. A rigid body is going to be the physics component of the game object. The rigid body will allow our game object to interact with the physics engine. There's one more basic component that we're going to need. We're going to need a collider, a box collider 2D. The collider is going to allow this game object to touch other game objects. Otherwise, it'll go right through them. Let's see what will happen here now. Now that he has a collider, let's see if he collides with the ground. So he has a collider, but he's still falling right through the ground. Pause the video. Why do you think he's not colliding with the ground? Do, 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 do. Oh, I see. If we click the ground, and I'm going to rename this to ground by clicking its name and changing it to the ground. If we look at the ground game object does not have its own collider. Colliders can only collide with other colliders. We need to make sure that the ground has a collider, box collider 2D. Make sure to use a 2D collider when you're working in 2D. Now when I press play, my character will fall down, and he will hit this collider. Perfect. We're going to look at one more basic feature of Unity that's going to be really important for understanding how to move things around before we continue. The last really basic thing, and I might touch on this in the next video, is that you see that the whole Unity world is made on this little grid of all these little squares. And in some of my classes in high school, I saw a grid of squares just like this pretty frequently. This grid of squares is called a Cartesian plane, or You could just call it graph paper. If you're in math class, it might just be called, take out your graph paper. Each of these squares represents a distance of 1. 1 is, arbitrary. There's no feet, there's no inches. It's just going to be called 1 unit. So if I set this guy's position to 0, 0, he will go to the origin point, right in the middle of my map, dead center. If I start increasing his x by 1, by 2, by 3, now he's at the coordinate point. He's centered on the coordinate point. X is 5, y is 0. The whole game is a piece of graph paper. If you move your eyeballs really close to your computer screen, you can actually see your computer screen is also like a piece of graph paper, where each pixel is a single point on the graph. In computer science, we use graph paper a lot. It's used for every position. The way Windows knows where different things are on my screen is Windows is using a graph, just like this. Everything in computer science is built on a graph, just like this. Everything your computer displays is put on a graph, just like this. When your TikTok decides where to put the like button on your screen, when your app loads, it's giving it coordinates, coordinate point locations on your screen. All programming language, whenever you're placing something on a screen, you're doing it with these math coordinate points. Everything is defined relative to some origin point or some other object on the screen, and they're given coordinate points relative to that object or origin. So we see that x, increasing it, whoops, that's the scale. I meant to increase the position to 6, moves it over to the 6 square, to 7, and actually the square itself, it's these points. These center points are x is 1, x is 2, x is 3, x is 4, x is 5. And as I go up, now y is going to be about 1 here. And then if I move up to this next line, y is going to be about 2. And then if I move up to this next line right here, y is going to be about 3, 2.97. If I move up to this next line, y is going to be about 4. And again, I'm not doing this perfectly accurately. I'm just showing you that we are on a piece of graph paper. As I go backwards this way, I get into the negatives. And as I go down this way, my y goes into the negatives. Every game, every enemy position, every power-up, every coin is placed on a coordinate point. If you want to be really good at making video games, it might be something worth reviewing in math class if you're not super strong with placing points on a piece of graph paper. But yeah, all of the positions are going to be placed relative to coordinate points. I think that is the most interesting things to start talking about for our little intro lesson today. And I'll say that if you can get on your own some Navy assets in and have them fall down with a rigid body component, rigid body 2D, and have them collide with a floor using a collider component, then that is a great start to your Unity progress. And we will continue in the next video. One last really important thing that we actually might want to know about using Unity is that sometimes we'll break something, we'll mess up. Maybe we move the scene view, and maybe we mess up like the inspector, and maybe we're missing a window, and maybe everything looks really strange and really weird, and we just break our Unity. We can't figure out how to get our stuff fixed. Anytime my Unity gets really messed up, what I tend to do is I go to layout and I just go back to default. If you guys want to learn different layouts, you're more than welcome to, but I like to just keep it simple and keep it on default. So that's what I'm going to be doing. Anytime you get stuck, top right corner, set your display mode to default.